So what you guys have seen is the power is given by P is equal to ERMS IRMS cos phi, correct? Or EV IV cos phi. See, suppose let's say you have I, correct? So I is the current which is passing. Now that I can be resolved into I cos phi and I sin phi. See, when I say I cos phi and I sin phi, we are talking about just the RMS value of the current. Okay. So I cos phi and I sin phi, the angle between them is pi by 2, correct? So we have the angle to be pi by 2. See, here the I cos phi component is in phase with the EMF, that is ERMS. Okay. Now, as you can see in this phasor diagram, so ERMS and IRMS cos phi, they're in phase, right? And then IRMS sin phi and E, they are at an angle of 90 or pi by 2, right? Now, see, we'll consider the first case, that is, we are considering the cos phi component. Okay. See here, IRMS cos phi and the ERMS. So these two components are they're in phase. So the angle is 0 degree, correct? So the power becomes E into I into cos 0. So cos 0 is 1. So you will get just E into I. Okay. Next, second case is we are taking the sine component, that is ERMS IRMS sin phi. Okay. So we are taking these two. Now the angle between them is pi by 2. Now if we substitute this in the power formula, then you will get cos of pi by 2, correct? So once you get cos pi by 2, cos pi by 2 is 0. That means the whole power in this is 0, right? Now what we can conclude from this is that IRMS sin phi for that particular current, for the whole cycle, that is for one alternating current cycle, there is no power consumed from this, or in other words, the power is 0, correct? Now this current is what we call as the idle current or Wattless current. Okay, because the total power is 0, right? So this is the reason we call this as a Wattless current. Okay. Now the whole power is given by just IRMS cos phi. Okay, that's why we have the formula ERMS IRMS cos phi. All right. So in the next video, you will see about transformer.